Hi. Let's talk a bit about what we're going to be covering in Precalculus. This will be the first lecture for the Precalculus class. Don't really think of a lecture, but it's a video. It's nice, you can pause it at any time. I recommend you doodle along with it. You can pause it, go get a sandwich or something. And I don't really like to sit in class and talk to you. Class time should be reserved for doing problems, solving problems, answering questions, seeing what you're having difficulty there, not just listening to me talk. So we'll have these so you can watch them at your leisure. You can pause them anytime, go get a sandwich, stop if your brain is full, and pick it up again later, or watch it in the middle of the night. So let's talk about precalculus. I don't really like the term precalculus. It implies that it's something less than calculus, or just a preview of calculus. It really is the heavy lifting of calculus. It's a really in-depth view of algebra and trig. This is a barbell here. It's the heavy lifting of calculus. Calculus has a reputation of being sort of the ultimate, the pinnacle of mathematics for college level things. But it really isn't. As you go in and become a math major, I'll keep trying to sell you on becoming a math major. It really is a wonderful, wonderful life being a mathematician. As you go on, you'll find there's lots of other bizarre areas of mathematics, and calculus is a very interesting area. It's very important to the sciences. But really, precalculus gives you a solid foundation in solving problems. Alright, so we're not going to call it, when I say precalculus, I want you to think of really as advanced algebra and trig. Advanced algebra and trigonometry. That's the class we're going to do. Advanced algebra and trig. So I want to do a nice diagram here of what we're going to be covering. I like to do pictures, because I just like to draw. I torture you with bad drawings. A lot of people say, oh, I can't draw. But everyone can draw, just badly. So I'm going to encourage you to draw, and I think you should doodle along with these as you learn. Anyway, so we'll start out with a foundation in functions. Now, you've been working with functions all your life. You've been solving algebra problems since you were a baby, and solving quadratic equations. But we're really going to talk about the detail, what's in functions. And the foundation of all analysis is set theory. Say there's a cow, pig, sheep. Any sort of sets. When you map one thing from one set into another set, take x's and map them into f of x's. This is set theory, and this is what a function is. We need a very good definition of functions, because we're going to be looking at pushing functions to the limit and see what they do under weird conditions. So once we have a solid understanding of functions, we'll go into typical functions that you're used to. Say, the old y equals x squared plus 2, or a linear function is just y to 2x plus 4. Function of a line is a linear function. And then we're going to be taking these, if it's x's to higher powers, we call these polynomials. We're looking at nice parabolas and things like that. And then other polynomials like cubic things. And then we're going to be dividing polynomials by polynomials, and we get rational functions. So this is the big arrow. I meant to make this an arrow. This is one area we're going to be doing, the polynomials. Something you're used to, but we'll go in a little more in depth. Let's see, what color should we use next? And then we're going to be going into exponentials. We have x squared, x cubed over here, but what if we have 2 to the power x, or 10 to the power x? What do these functions look like? Y equals. We're going to be using a special number, e, which has really nice properties for our exponentials quite a bit. And the opposite of an exponential is a logarithm. So logs, which are sort of, I don't know, some people think they're very backwards, but they really are very useful. I use them a lot in my work. And we'll be talking about exponential and logarithmic functions. And I'll say this third area, what color will I use? Blue. It's probably I want to make this area very big because we're going to do a lot. We're going to be doing a lot of trigonometry. And these are sines and cosines. Things you're familiar with before. We'll start with the right triangle, the wonderful right triangle. Remember the opposite, hypotenuse, all that good stuff. And we'll look at this and we'll put it on a unit circle and we'll look at periodic, we'll develop this into looking at periodic functions. Things that repeat themselves, whether it be weather cycles or sounds or sound waves. Any kind of waves is very important for lots of engineering and science applications. But we're going to look at them sort of just from a math point of view. They're wonderful problems to solve, and they give you great insight into what's going on. Any sort of equation can be modeled with sines and cosines. And we'll have equations with sines and cosines in them. In the last section, we'll say for purple, is we're going to push functions to their very edge and take a look at limits of function. And this is sort of the gateway to calculus. You'll really get the fundamentals of calculus in this pre-calculus class. So it's sort of a misnomer. We'll look at the limits of functions. Some functions, their domain and range, things we were talking about down here. Oops. They don't really have a value at certain places, but we can take a look at what happens as they approach that. Or we can take a look at what happens to, say, the slope of this line as this triangle gets smaller and smaller. And really what we're doing is we're taking a look at finding slopes of lines and summing up, adding things, and looking at as widths get smaller and smaller. So take a look at limits will be our last thing here. And this is the great universe of pre-calculus. In here is all kinds of wonderful problems. We'll be talking about complex numbers here too. I like to throw that in. Nothing very difficult, nothing you haven't seen before, but very in depth. And we'll get through and solve a lot of interesting problems in this course.